Welcome to this session on transforming your finance function with Power BI, Microsoft Fabric and generative AI, including Copilot. These are all big buzzwords at the moment, and for good reason. They're in the process of transforming how we think about business processes and analytical reasoning. So far, there's been a lot of focus on creativity with generative AI, asking it to produce social media posts, summarize lengthy documents into bullet points, write original content based on existing materials. And that does have some application in business teams like finance, such as automation of financial commentary. But many of the processes in finance is not producing or summarizing content per se. In fact, the tasks which take up the most time and are potentially the least enjoyable for the individuals involved are around data cleaning, data preparation, and data modeling. Taking data from financial and operational systems and combining it so that it can be consumed for analytics. This includes all the standard extract, transform, and load operations that are done as part of a data platform, such as Microsoft Fabric, but also the analytical layer, which Power BI, now one of the Microsoft Fabric tools, is ideally suited for. This is the layer where finance professionals can add context to the data, provide it with that meaning so that it can be reasoned over by generative AI, and those insights can be automated. This includes building the right calculations and shaping the data into the right structures. Here we'll explore all of this with a full end-to-end analytics workflow in mind. It's the combination of all these aspects that I believe really drives business change through technology rather than building technical solutions for its own sake. Just to set the scene, I'll start with a bit of background to me. I come from a bit of a mix of business and technology areas. I'm a chartered accountant and graduated with honours from an executive MBA program last year, but I'm also a Microsoft MVP, and my day job is working for the largest Microsoft partner globally, a company called Avanade, which is a joint venture between Microsoft and Accenture. I'm also obsessed with making learning engaging. Learning technical tools such as Power BI through generic courses or online material is challenging. The volume is overwhelming, and there's a large gap between passively learning general technical concepts and applying them to a specific business domain such as finance. It's hard to find the time to complete self-paced on-demand content, and for many people, they don't have anyone to go to when they get stuck. I think the best way to learn is through engaging e-learning. The MBA I did last year was actually all taught through questions and exercises on a mobile app, and directly from experts in the field, learning along with your team or with your peers, trying out realistic exercises or challenges that are directly relevant to your role. So I run a cohort-based course for finance professionals at www.powerplatformfinance.com, which is a mix of e-learning and instructor-led training as part of a small group. Let's start with taking a look at a bit of an overview of Power BI and Fabric Copilot. To start, I want to provide a bit of context around how data roles in the traditional operating model work and how I see that as being different with Microsoft Fabric. So these data roles could be represented by this pyramid structure. At the bottom, the vast majority of the organization, we have data consumers. They're not responsible for producing analytics, but rather just consuming the outputs. Static PowerPoint decks, for example, complete with a narrative, or data stories, or interactive reports in Power BI. We then have data explorers, and these are the individuals responsible for producing the data stories based on the curated data sets produced by those higher up in the pyramid. They can use Excel and perhaps Power BI for visualizations, but they likely don't know Power Query and DAX to do the analytics works themselves. Then we have the red belts, who are the data analysts and the data scientists. These people live in a self-service analytics world provided by tools such as Power BI. They work on automating existing processes and building business domain logic in Power Query, DAX, and perhaps Excel, VBA, Python, and R. They typically don't have direct access to source ERP systems, but rather access data warehouses developed by the data engineers, the black belts. They do a lot of valuable work, but they typically work in a world of shadow IT. And then at the top of the pyramid, we have our black belts, who are our data engineers that typically worked in Azure. Now, these people typically only exist in the IT function, especially in large organizations, so they don't really have the business domain specific knowledge and can't bake that into their solution. But they work directly against enterprise source systems, such as ERP applications. and they ingest the data into a data warehouse or data platform in a consistent, scalable, and performant manner, with massively parallel processing architectures, separation of storage and compute engines, and centralized security. This really allows an organization to be able to apply that enterprise-level security and governance to solutions and deal with structured, unstructured, and real-time data. These data engineers have specialist skills, and whilst having these specialists seems efficient, in reality it has a number of challenges. The data engineering and the BI data teams end up becoming a bottleneck. So as much as they can provide data warehouses, they can provide clean and curated data, this is a long process. It typically takes months to gather business requirements, to set up the infrastructure, to design a solution, and then to build it in a platform like Azure. And business users just end up taking the data and bringing it into Excel to be able to apply their own business logic to it and combine data together anyway. This creates data duplication, silos, and makes a CDO's job of trying to harmonize data quality, data security, and governance across all of these systems and platforms an almost impossible task. It's come up with Microsoft Fabric, a unified platform that brings all of these Azure Data Platform tools like Data Factory pipelines, warehouses, and notebooks into the same software as a service environment as Power BI. So these can all be set up with a single click. Moreover, the data is in a single format across all of these and doesn't need to be moved from one environment to another. The data is stored in one lake, a data lake, in Delta Parquet format, and all of these workloads, including Power BI, work directly on top of it. The aim of this is to help eliminate those data silos and complexity. All of those personas that we saw in the previous slide work in the same environment, all within Microsoft Fabric, and they work with the same copy of the data. And there's a consistent governance, security, and access layer across it all. It's also designed to appeal to the skill sets of both traditional data engineers and low-code analysts who are used to working in Power BI. You have data flows from the Power BI world, as well as code-first tools like notebooks for shaping and cleaning data, and Copilot experiences across all these areas to enable more to be driven from natural language prompts. In the new operating model with Microsoft Fabric and Copilot, the red and black belt personas are merged into this analytics engineer role, shaping and curating datasets to prepare data for analytics in an enterprise fashion. And then there are developer or creator copilots to help with this. And data explorers and data consumers can then also leverage Copilot to automate the insights from these datasets, and as such could really self-serve on the data rather than relying on the levels above to produce the pre-canned reports and decks for consumption. There are three main Copilots currently in Microsoft Fabric, though more are being continuously released into literally every workload experience within Fabric. Within Power BI, we have both Report Creator and Report Consumer experiences. For data transformation shaping and preparing the data for analytics, there are Copilots within notebooks to help write PySpark code, and in data flows to help with transformation steps in Power Query. There's also other Copilots, such as SQL Copilot, to help write and explain SQL queries, and Copilot for Custo, where you can translate from natural language or SQL code into Custo query language, which is the language used for real-time intelligence. Just to hone in a little bit on the Power BI Copilot experience, we have Copilot to help with creating reports. So these are reading the table, column, and measure names and looking at the data in order to suggest report content and creating simple base visuals for these reports. And for report creators, you also have Copilot to help create DAX measures based on natural language prompts and to understand or create descriptions for existing measures. As a report consumer, you can ask questions of the report or of the data and can ask Copilot to summarize the insights displayed in a report or of a dataset. You can ask questions about the dataset. For example, tell me how this measure has trended over time. We've also started to see how data within the Fabric data platform might be brought into other Copilot experiences through things like AI Skills, which we'll look at also at the end. But we're also not restricted to Power BI and Fabric Copilot. You could use ChatGPT or Perplexity AI or anything else as well. And if we look across the whole analytics workflow, Copilot only covers some of the areas. This is a diagram from a white paper written by Accenture employees that outlines the analytics workflow and looks at different types of tasks, creative assistance tasks, and automation tasks that could be helped using Copilot and generative AI in general. We can see that Gen AI can help with user and design requirements. It can help with preparing, cleaning, and structuring that data into a star schema for Power BI. It can be used for wireframing and designing the reports, and obviously for the consumption experiences of explaining and summarizing the data. Right, this is what we'll be covering through this session. The first thing to do with any data analytics project is to start with the end in mind and work out what insights specifically you want your audience to be able to get from the data products that you build in Microsoft Fabric. This is not obvious, and it's not something you can do after you've built your analytics data products. You need to build specific data products for specific audiences with specific pain points, rather than trying to build a solution that is all things to all people. So the first few steps in here are around doing some initial exploration of your data. Here, a suggestion using Power BI Copilot, identifying who your audience is and what insights they need, and then designing a corresponding Power BI semantic model. This semantic model in Power BI has your data in the right structure. It has the relationships between those tables, it has the DAS logic, and it has things like row-level security built in as well. These semantic models are really key to be able to derive the kind of insights that you need from Copilot. Next, you need to clean and shape your data accordingly to get your data from its raw format into the star schema data model that you need for Power BI. This includes putting the right logic, but also the right metadata. So things like table and column descriptions can be referenced by Copilot, as well as synonyms, so that Copilot understands your own business lexicon. And you could use a developer Copilot in Fabric to help with this. You then need to create reports in Power BI, and I'll show some examples of Power BI visualization techniques I've used, as well as being able to get insights using the consumer Power BI Copilot experiences. And then we've also got looking at publishing those models and say, bringing it into other Copilot experiences or making it more accessible beyond the experience of Fabric and Power BI. And that's something that Microsoft are continuing to invest in. I'll show some new features in this space, such as AI Skills, and actually just calling Azure OpenAI with a notebook to create our own vector search index. This is a bit of a hint around where I see things really going with Gen AI and LLMs, especially creating our own Copilot models based on our enterprise data directly within Fabric, which is where our data already lives. Let's start with having a look at the data that we're going to be using here. We've got actuals data, which is a bunch of CSV files, one for each month. We've got budget data, which is an Excel file, and reference data, which is an Excel file. So if we look at the actuals folder first, this contains 3 years worth of data, so 36 monthly CSV files from July 2019 to June 2022, which we need to combine together to be able to have it in one table. If we open up one of these files, we see that we have some header rows at the top, which we don't need, so we'll have to get rid of these when we combine the data. We then have keys, so organization, department, account, and a date, and then the amount in local currency. The local currency relates to the location of the organization unit in which the transaction occurred. Let's have a look at the budget data. So the budget data is actually at a month level rather than day level, and we don't have departments. We don't have budget assigned to particular departments, only at organization level. We have a budget type of standard or rebaselined, and we have a budget amount also in local currency. If we now look at the reference data, so the first reference data sheet is our chart of accounts, and this is fairly standard with every accounting data set. Our journals are always booked against 2 accounts. We just see the income statement ones here. We have our account and what type of account it is, revenue or expense, and because this is just income statement, it'll be one of those. And then where does this sit in the income statement? Is it a revenue line? Is it an operating expenses line? This links into what we have here, which is our income statement layout. This is a manual helper table that has the chart of accounts headers in there, but also our subtotals like gross profit and our calculations like gross margin, which is gross profit divided by revenue, and laid out in the exact order we want it to appear in. Here next we have dates, just continuous list of dates, standard in the Power BI file. We have departments, just a list of departments, and the department names and department parent. And then we have organizations. So organizations, this is each organization unit, the name of the organization unit, and most importantly, the currency code. So those actuals or budget amounts, which are in local currency, this is the currency which they're actually in. And lastly, we have exchange rates, and there's 1 row per date for exchange rates for euros, GBP and Australian dollars into USD, which is our reporting currency. Obviously, it doesn't make sense to add numbers in euros, pounds and dollars together, so when we look across the organisation, we have to firstly convert the numbers into a current currency, which will be USD in this case. Now we're going to look at the first step in our analytics workflow, which is data exploration. There's lots of ways to explore data, and we should check things like data quality when we first get it. But here I want to focus on figuring out the type of insights we might be able to get from it. Here we've loaded in all of our CSV and Excel files straight into Power BI. We've used a folder connector to combine all the actual CSVs, and there's just the default relationships in place here. Our actuals, budget, chart of accounts, and our reference data files there as well. And what we're going to do here is just ask Copilot to give us some examples of topics for analysis. Firstly, we're going to ask it to describe this dataset. And it gives us quite a good description of what this dataset is. It's actuals and budget amounts across different departments and accounts. And another suggested prompt was to suggest content for report pages. And again, it gives us some really interesting types of analysis that we can do. So we've got here financial performance of different departments and organisations, budget versus actuals, exchange rate impact, and income statement analysis. When we click create for any of those, it will then generate a prompt for us automatically here. So this one says create a page to analyse financial performance, and then it creates the visuals for that page. Now we can see the visuals that it's created. It's a few simple bar graphs. It's okay, but what's really lacking from here is any context to those numbers or any specificity. It's just all the data, all of the amount in local currency. So adding together amounts in different currencies, which of course makes no sense. And what does that number really mean? Is that good or bad? We can actually see some of the numbers look the same in the bottom graph. So it suggests that a relationship might be missing, which is fine. That's something we probably need to go in and fix in our data model. So if we were expecting it to give us a complete usable report, then we'd likely be disappointed. But actually this is quite useful for us to get a view of the type of analysis that we can do. We can take this to our stakeholders and say, what about doing an income statement analysis? Is there value in analysing the exchange rate impact? Especially if you're not from a finance background yourself, that's going to make you sound pretty clever coming into that stakeholder meeting. And we've asked it here to analyse financial performance based on the visuals in this page. So it does actually give us a description of what data is shown in those visuals. And here we're looking at budget versus actual. And again, it's giving us some graphs. It's not really giving us a variance or anything that we could work with here in terms of budget versus actual or what's driving those variances, which is what we'd really want to see here. But again, it's a useful starting point. And lastly, we look at exchange rate impact. That's going to come up next. And again, I think this is okay. It gives us an idea that we might be able to have a measure that is average exchange rate over the period, for example. And these graphs are all simple at best and misleading at worst. So don't use them as is for your actual visualizations. Even for things like income statement analysis, there's lots of things we would have liked to see here, like an income statement for a given month perhaps, and that's just not what Power BI produces currently. But again, I think these are really useful starting points and something you can take to those initial stakeholder conversations around what it is that you actually want to do. We've asked it to say a formatted income statement and it can't do that. We've asked it to add slicers and it's not really able to do that at the moment. But again, I think it's useful for doing that initial type of thinking. And this is all about managing expectations of what Power BI Copilot is useful for right now. So now we're going to look at the second step, which is requirements gathering and data model design. And we're going to use ChatGPT to help us with this. It's not something all analysts are really used to doing. So we start with a transcript of an interview between myself and a hypothetical finance manager, where I'm asking what kind of insights they'd want, what business questions they really want to answer, what context do they want, how are they going to be able to evaluate performance of, and what are they going to do with that data. And these are really useful questions to ask. Note that I'm not asking what visuals they want to see on the page. We can work that out once we know what it is that we want to show. Now, we need to translate that into what kind of data model do I need to build? And what kind of story do I need to build around this data? So this is an example of a scoping template, a very simple one-pager, which I've been using for a long time. It shows for each area of a report, who's the audience for this? What's the key questions that we want to answer? What measures do we need to be able to answer those questions? And what do we need to view and filter by in order to get those insights? Those of you with a BI background will recognize this as facts and dimensions, but we're not using those technical terms here. So here now we're putting this template into ChatGPT and say, here's the interview transcript. Use this to populate the attached scoping template. Tell us which business questions are being asked for and what we need to view and filter those by and what measures we need to have. So this is what it produced. Here we've got a problem statement. The finance teams need detailed and automated financial reports that provides key insights into performance. There are some of the key questions. What's the monthly performance and so on. And this is an example of one that I completed earlier. There's a bit more context to these questions that I put in here, asking things like what's driving the variability. So a bit more detail than ChatGPT gave us, but I think ChatGPT gave us an actually pretty decent starting point to expand on. The next thing we need to do is to start thinking about designing our data model based on this. And that starts with analysing the data and saying what numerical data points do we have by which attributes. In other words, which numerical data by which dimensions and by which grain of dimensions? Is it by date or only by month, for example? We might have numerical data scattered all over the place. A template we could use for this is a bus matrix. So numerical data points and then attributes down the left. And we indicate whether each of those numerical data points are by those attributes. And again, we're passing this into ChatGPT and say, please populate the attached bus matrix template based on the contents of the data. So we've given it the data in a zip file and the bus matrix, and it hasn't really been able to populate the template. It's started to get the idea. So maybe this template really wasn't the kind of format that it knows how to deal with. But again, it gave us a starting point for that. And I can show you an example here of a completed template showing a bit more detail about what we were actually after. We can see we have the ticks and crosses to highlight that we have our actuals by date, but we have our budget at a month level. So we can see tick, stroke cross overall for the date dimension, and then a cross at the date level, but a tick for some of the high level attributes. So instead, we can ask ChatGPT to just populate a normal bus matrix in whichever format it wants, and it's given us a very high level one there as well. Lastly, once we've done the bus matrix, we also want to look at this idea of conceptual modeling. So this is where we use a conceptual model diagram, like a star net diagram here. We have a circle in the middle, which we populate with our numerical points or measures, and then across all the branches, we have our dimensions and attributes. This is a way of representing the fact and dimension table structure that we want before we build it. What do we want to have as our fact table in the middle, and what do we want to have as our dimensions and attributes? So again, we've given ChatGPT our completed bus matrix, and now said, please use this in order to populate the star net. Let's have a look at what it's done there. And you can see it's put some of the actual attributes, but it's just listed them out. It wasn't able to put them into text boxes and shapes. And to be fair, asking ChatGPT to populate shapes and text boxes in Word is probably a bit much. But this is an example of a completed star net. We can see we've got two fact tables, two diagrams, actuals and budget. For actuals, we've got our mounted local currency and reporting currency, and in the branches we've got organisations, chart of accounts, income statement rows, and so on. And again, same with budget, one less dimension there in terms of the departments, but very similar in terms of organisations, chart of accounts. Let's again ask ChatGPT to just produce a conceptual model in whichever format it likes, and it's produced this conceptual model diagram here. Not quite what I was after, but again, maybe this is something that's going to get better, or that we could build custom GPTs for. I did want to try this with the new L1 model, but at the time of this recording, that doesn't support file attachments, so this wasn't really possible. Now we move on to the actual tech. We're going to look at data shaping and transformation within Fabric. That conceptual model from the last section is basically the blueprint for our ETL work, the work we need to do in Power Query or in Fabric to shape our data, of course, using Fabric Copilot. We're going to use here what's known as a medallion architecture. In Fabric, we have workspaces and lakehouses. We'll set them up so that we have bronze workspace and lakehouse for our raw data, a silver workspace and lakehouse containing clean data, which is to be combined, and a gold workspace and lakehouse where our data is shaped into the set of factor dimension tables that we need for Power BI. So here's our bronze lakehouse. There are two sections to a lakehouse, tables and files. The file section is like a normal lakehouse, which could contain any kind of file, PDFs, Excel files, and you can actually synchronize it with your machine using OneLake File Explorer that works the same way as the OneDrive app on Windows. Or you can upload files from your machine directly here, or of course connect to a file-based data source. So in our case, our raw data in bronze is just files, so that's all this lakehouse contains. But now let's move to the silver workspace. And here we want to have the data in the table section of our silver lakehouse, with the data combined and cleaned, and any calculated attributes we want also applied. In the table section, our data is stored in Delta format, Parquet files with a log transaction file in the root folder. This is a standardized format for analytics, which makes them available to other Fabric workloads, including Power BI. So what we're doing here in the silver workspace is connecting to the bronze workspace and creating a shortcut to the files. We start with creating a lakehouse, we create a silver lakehouse, and then in the file section, choose the option to create a shortcut. Choose OneLake as the source, select the bronze workspace, lakehouse, and the data folder in there. This is a reference to that data, so it's not copying the data physically over, it's just pointing it as a reference in this lakehouse. Now that we have it here available in this lakehouse, we could work with this in notebooks, for example, combining and cleaning the data and saving the resulting data frames as delta tables. Here we create a new notebook, and notebooks allow us to write code against any of those tables that sit in our lakehouse. They're based on Spark, which is a language designed to work with big data. And we've also got Copilot here. So we click on the Copilot button, we first install the library, and here we've got a prompt to say, can you combine all the CSV files in the actual folder into a single data frame and remove the headers. And we can see it's given us the code for that and described the code. And the description is actually quite good. We can insert this code straight into the notebook and run it. So it says import pandas, puts the file path, and then for each file in there, loops through each file and adds it to the data frame. So it seems to have done quite a good job of that. Next, we've asked it to show the total value for each month in the combined data frame. This would be useful to sense check the data. Perhaps if we have these values calculated somewhere else, we could use this to check to make sure it's all combined the data properly. We've also here asking it to link in the organization's data and pick up the currency from there. In the prompt, we tell Copilot we've got the date in the actual data frame and ask it to merge that with the exchange rate on date and currency code. Now, I wasn't specific enough as to where all that data sits, and it's not going to scan my data and try and figure it all out for me. So it's giving me an error here saying that no file exists, there's no such organization CSV in the folder. But we can go back and ask it to correct the code. We can tell Copilot that it's actually an Excel file, not a CSV file, and that this is the location. And now it's rewritten that code. It's important to note that if it comes up with an error message, we can actually pass that error back into Copilot and ask it to revise the code. It might take a couple of attempts, but generally that will give us what we want. And this knowledge of the exact environment and data and the code it is operating in is a key advantage to using Copilot over something like ChatGPT. Now here, we're also looking at Copilot in data flows. So it's data flows Gen 2 in Fabric, Power Query Online, which are almost identical to Power BI data flows. So here the data flow is created in the silver workspace and we're connecting to files in the bronze lakehouse, applying our transformations and combining our data, and then writing the outputs of this data flow as delta tables to our gold workspace and lakehouse. If we wanted to be a bit more purist with the medallion architecture, we could have connected to the silver lakehouse with our shortcuts, but it makes little difference here for us. We're using a combined binaries feature to bring in here all the actuals data. So this is the same Power Query features and code that we have in Power BI Desktop. And we can actually copy and paste the queries from there. And we also have Copilot here to be able to help us with transformations. So let's open up Copilot. Yeah, and we don't need to install any libraries. and it gives us some ideas about what it can do. It can create new queries, it can add steps to existing queries, or it can describe existing queries or steps. Let's ask it to do something. So we're saying here, add a column to this table that brings in the currency code from the extract organizations table, linking on organization key. And it's created a join there, a merge between the queries on organization key, and it seems to have brought in the currency code. That would have been quite simple to do in the UI. And I guess actually this is one of the challenges I have with Dataflow's Copilot. You have to be very specific with these prompts. You have to know exactly what you want to ask for. And if you knew that, then you'd also know the steps that need to be applied. And the chances are you already know how to do those steps in the Power Query UI, because that's how you know the steps in the first place. But anyway, as the next prompt, we've asked it to join on transform exchange rates on date and currency code and bring in the corresponding USD per unit. In Power Query, we can do a join on multiple fields. And we can see here, it's brought in the USD per unit. Just waiting for that to load. But there's a problem here as well. We can see that it's got a red bar there at the top, which indicates that it's produced errors. Looking at the steps that it's generated, it seems like it's because it's added this extra step in here. It's got join tables, and then it's added in a divide. I guess because it's got the word per unit in there, it thinks it needs to do a division calculation, even though in this case that just happened to be the name of the column. So let's delete that step and take off the comma, because we can't have the comma and a comma in the last step. And now we can see that it's given us the USD per unit without any errors at all. So lastly, let's ask it to add in a custom column. So here we can say add a custom column to return the amount in USD. If it's null, i.e. if the org unit is in the US, there is no corresponding exchange rate for USD to USD, it's just 1. In that case, return the amount in local currency. Otherwise, return the amount in local currency multiplied by the USD per unit. And that's actually given us that calculation there. And we can see in the formula bar, it's calculated that correctly. And then here for the end fact and dimension tables, so all those queries we had in the load folder, we set a data destination. This is going to output that cleaned and transformed data into a lakehouse as delta tables. We've set lakehouse as the data destination here, and we can choose the lakehouse. So now we're going to choose our gold data set and our gold workspace. It's also then just mapped across the columns, removing any spaces in the ones and the corresponding data types. So all of that looks quite good. Here we're specifying the lakehouse name, and we can see here the data types. So it's mapped across the columns, removed any spaces in the names, and set the data types accordingly. We have now that we've got our fact and dimension tables in the lakehouse, we want to build a semantic model in direct lake mode directly on top of those lakehouse tables. This semantic model will include all our relationships, our DAX measures, including descriptions, and other metadata such as row level security logic and what is known as a linguistic schema. And we'll start with looking at a few different ways to create measures, and actually start with copying everything from an existing semantic model and reporting input mode that we have in the workspace. So here we are in our gold workspace, and we can see here the gold lakehouse. This is all the outputs from our data flow, our chart of accounts, our budgets, actuals data, and so on. If we go back to the workspace, we can also see an input mode model and report that we've built in Power BI Desktop that's connected to those files outside of Fabric. We can see the report here, and we want the same report, the same visualizations, but have it based on the new direct lake data model built on top of our gold lakehouse tables. And we can actually run a script that's been provided for free by Michael Kowalski and Microsoft to do this. This uses a library in a Fabric notebook called Senpai, which allows the notebook to connect to semantic models. Going through the code, it starts off by setting all the parameters, and then the first step is to create the lakehouse tables by taking the Power Query from the input mode model and creating it as a data flow in Fabric that can output to a lakehouse. Now we've already done that. Our data flow is slightly different from the input mode model that it connects to in Fabric Lakehouse as a source. So we actually don't need to run this step. But the next step is where it reads all of the measures and semantic model objects and copies them into the new direct lake model. In this case, it didn't complete the process. It had a couple of errors, so some objects in my model that were unsupported, but hopefully you get the idea. Now we can open the new direct lake data model here, and we can also add measures directly. So we can click on new measure and just type in the measure that we want. And lastly, the third way to create measures, we've got the measure here, and the last way to create measures is the DAX query editor. So this is a really nice feature that's also in Power BI Desktop, which allows you to define measures and run queries to see the outputs of them in a nice DAX editor, similar to DAX Studio or Tableau Editor. And for any existing measures, you can automatically create a script to define them. So this is showing us creating the DAX script for all the existing measures in Power BI Desktop for our input mode model. And with a few tweaks, we can then copy and paste them into the DAX query editor in Fabric that is against our direct lake model. This would have come over already if we used all the pre-built notebooks, but actually this is just another way of bringing in those measures if we've created just a direct lake model and a blank direct lake model and brought them in. So we go in here, paste the code. Looking again at the DAX query editor, one of the key benefits is that it also has Copilot to help us write measures or explain existing ones. Here's a prompt asking it to write a measure for the cost to income ratio, which we tell it is operating expenses as a proportion of the revenue. And it's given us the measure there. And actually that looks correct. We can also ask it to describe this measure that's just been created. So we've updated our model with it and asked it to explain the DAX query. And it's given us a description of what that cost income ratio actually is. And it says it's used as a profitability measure. So I'd actually take a guess that most semantic models don't have measure descriptions, but these descriptions, whether generated by Copilot or by ourselves, are actually really useful for Power BI Copilot, for the consumer Copilot, to be able to understand what measures to use based on the prompts being asked. And so this metadata has taken on a whole new world in the world of Copilot. So to add a description, we can go into the model view, click on the measure and the description in the properties pane. This is what Copilot has suggested as a measure description. Sometimes it's not very detailed or specific. We can try again, or we can copy the one that it gave us from the DAX query view. In this case, I think that was a better description, even though it's the same Copilot being used to generate both. The other thing we want to set up for Copilot to work properly is this idea of a linguistic schema. One aspect of this is synonyms, i.e. the language that users will use in a prompt that will be specific to your organization or industry, which may not be exactly the same words though in your data model. The table, column, and measure names are the most important, but sometimes users might use a different word in a prompt to mean the same thing. Here we can see that against each one, there's a lot of suggested synonyms based on Copilot's understanding of the English language. So for things like profits, it will say earnings. Things like revenue will have turnover. We don't need to add these, but there might be some organization-specific ones where you might want to tweak the synonyms list for a bit. So for example, here we've added one in for revenue actuals, and we're just adding turnover as a synonym rather than turnover actuals, which was the automatically generated one. So all the measures are in here as well, and we can add synonyms for the measures. Perhaps if the measure names have been kept short, using an abbreviation, for example, then we might want to do that. And there's also this idea of relationships in the linguistic schema, which are not table relationships, but rather how action words in a prompt, verbs, relate to a measure. So here we can define things like what it means when a user asks in a prompt how much each organization has earned or spent last year. Copilot won't necessarily know what those terms earning and spending mean because we don't have those words in our data model. So we can define a linguistic relationship to tell it that organizations earn revenue. They also spend operating expenses or spend on another cost measure. And actually then it will know how to interpret those when people ask them in the prompt. Next, we're going to look at the fifth area here, which is storytelling with Power BI visualization. This is where we're going to look at the report that I produced from the dataset, not the visualizations that Power BI Copilot generated. We could perhaps use that as a starting point, but rather a report that I think really highlights some of the type of insights we could get from a board pack in Power BI. This is the first page of the report. At the top, we highlight the key metrics with a trend line and a comparison to the prior year using KPI cards. Underneath, it's showing a fully formatted income statement. We've got actuals, budget, variance, prior year, and variance to prior year percentage. The income statement has the lines from the layout table in the right order, with the hierarchy as well. And you've got numbers and percentages all formatted correctly in the same column. And when we select a particular organization unit, then it makes sense to show the local currency amounts formatted in the appropriate currency. So everything then just updates to show for that org unit the local currency amounts with a currency symbol as well. We can look at it monthly, we can look at quarter to date, or we can look at year to date values. Those are really important time-based views for finance. And when we hover over a line on the income statement, we've got these report page tooltips to see what the trend within the month is. It shows how that number is made up by the daily amounts within the month. And we've also got this drill down capability, so we could drill into any line or subline in the income statement and say, I want to see all the returns and adjustments for this period. And it will go in and show us all the journals and transactions that make up that number. This is really powerful to allow your stakeholders to self-serve on the numbers, rather than coming back to the finance team if there's a number they want to see the details behind. They can go and do that themselves. We also have this waterfall chart at the bottom, so we can see our total net profit. We can see that 1.3 million was the current month's net profit, and the previous month it was 2.1 million. And we want to see which organisation units have contributed to that difference, that decrease in overall net profit. Actually, one org unit has had a small increase in net profit, and 2 have had a decrease. Producing this takes a bit of customization from the native waterfall visual, so that we can show a value at one point compared to a value at another point, and just a breakdown as the difference between them. Interactivity between visuals is also a key feature of Power BI. If we click on a particular line in the income statement, then it cross-filters to that. So now we're looking at revenue, 8.3 million this month and 9.3 last month. And we can see European operations is responsible for almost all that decrease in revenue overall. We have MTD selected, so we're looking at monthly revenue, but we can also look at our quarter to date or year to date as well. So we can start to see how this really gives us insights into our financial performance. Here, we're using bookmarks to show a different view of the income statement. Rather than showing all the measures as columns, when we click on the bookmark, it's going to actually show just actuals, but broken down by the various different organisation units along the top. This is making use of some of the interactive features of Power BI to be able to really tell that story. Also, row level security is really important in a finance context. So here we're setting rules for a group, say those who belong to the US org unit, for example, where they can only see their own data. And especially with sensitive financial data, this is a really important thing to be able to do. Once we define the rule, we can go to Power BI service and assign people to these. And then when we publish it, we can see what it looks like for the US team. So here now we're selecting what with the US team. If someone was logged into the service and they belonged to the US team, what they see. Lastly, let's look at Copilot for storytelling. And by far the best Copilot enabled visual for this, I think, is a smart narratives visual. It is one of the best uses of Copilot. And in financial reports, we always need to have a narrative there to explain what the graphs are showing. So here we said, can it summarize? Can it give us an executive summary? It's a bulleted list of insights, or answer likely questions from leadership. And by default, this will pretty much explain what the visuals on the page are showing, but put them into words in the format you've asked it to. Whilst by default it's limited to the visuals that are on the current page, we can also tell it to consider other visuals as part of its narrative. So here we're also asking it to look at the income statement matrix that we've got on our first page, because that's going to give us then a level of detail that we want, i.e. it's going to explain not just what is happening to our ratio, but which lines on the income statement for the same period are driving it. And we're being really specific about the detail we want by entering our own prompt. So we're copying in a prompt to say use this income statement matrix to really explain why there's a difference to prior year, not just that there is a difference, which is what we can see in the graphs. So which specific revenue or expense lines are causing that to be different. And we can see now it's talking about things like labour costs and highlighting labour expenses have gone up and marketing expenses have gone up. This is now a really useful narrative for end users of our report. That narrative updates as we change the field parameter value here. We can go and refresh that Copilot visual and it will update. We've used the developer capabilities of Power BI Copilot. And we also want to think about the consumption experiences. So what consumption experiences will help us get the insights from our reports and data model. But yeah, now let's have a look at this in read-only mode as a consumer. So we click on Copilot and it opens up this pane. We ask it to give us an executive summary of this page, and it's given us quite a lot of detail. It's told us for this month that we've got selected here, this is our revenue, this is our expenses, and it's highlighting the trend. We can also follow up, asking it, for example, which insights should I focus on in this page? So here, which insights should I look onto on this page? And this is one of the default prompts. Where we have quite a few visuals or quite a lot of information presented, it will summarize those for us in Word format, which, when combined with the visuals, I think really helps to paint the picture. So here we can see it's telling us about revenue, actuals, the trend of those, operating expenses compared to prior year, significant difference in the profit by the different geographies. And this is really useful. I suppose the other thing to think about is what if none of the visuals in the report answer the questions your stakeholders have? By design, we've only answered specific questions with the report that we identified at the beginning, but what if they have other questions? And this is where this answer the data question comes in. It's where Copilot prompts to query the data model to answer a specific data question. So here we're asking, how does the profitability performance in June compare to the previous months of the year? So just copy that prompt in there to say, how does the profitability performance? And it wasn't able to answer this properly, but it's asked for some more clarifications. So it shows that we have to be very specific with the prompts that we ask it here. But that's fine, we can reword that. So now we've asked it to give us a trend for net profit margin sorted by month and year, and now it's given us that trend. This wasn't actually a graph that we had in our report, so it's a good example of something specific our stakeholders might want to see that we haven't answered through our report. We've asked it, why is there a dip in the, here you go. So we've asked it to show net margin for each month in 2021 and 2022, and now it's produced that as a graph. So the first time the wording was slightly different and it didn't quite pick up what I was after, but it's done that here. I'd say a good example of something specific our stakeholders might want to see that we haven't answered through the report. And we did also ask as well, why is there a dip in the net profit margin in January? And I think it wasn't able to necessarily do that properly. There is that kind of capability in Power BI within the graph to be able to explain the increase or decrease, but this is traditional AI capability is still separate from Copilot. And I imagine at some point we'll see it all start to come together a bit more. Next, we're going to look at box 6 here, which is AI skills. So this is converting our prompts into queries, specifically SQL queries, against our lakehouse tables in Fabric. This is basically a custom Copilot. We're giving example prompts and clarifying or codifying into the Copilot experience how to translate those kind of prompts into queries to return the right answers, which tables to look in, how to navigate the relationships, and how to calculate the required results. For this, there's a new feature in Fabric called AI Skills. So we can see Microsoft's description of it here, creating AI-powered workflows over your data and connecting to these to Copilot and applications across Fabric. So we firstly choose a lakehouse to connect to, and we're going to connect it to the gold lakehouse here that has our factor dimension tables, our conform data. and we select the tables that in that lakehouse that we want to connect to. Bear in mind that this is in a semantic model, so there's no point in selecting a measures table, which is empty. And at the moment, we can't refer to any measures in our model. I'm hoping that in a future iteration, we will be able to. We've selected our core factor dimension tables, and now we're just going to ask it a question here, giving it an example prompt and seeing what it comes up with in trying to convert that into SQL. We ask here a prompt, what is the total profit for June 2022 and 2021? And even though we haven't actually told it how to do the relationship to the date table, it's figured it out. The query contains the SQL join on date key, and it's filtered out and given us total actual amount, which in our case is actually equal to net profit. Although this number isn't quite right because some of our values are negative and some are positive, which isn't reflected in our actuals data column. But let's ask a more specific question. What's the total revenue for June 2022? Now the question is it going to know what revenue means? We don't have a measure called revenue here because there's no measures. And it's essentially given us the same query here as for net profit because it doesn't know what revenue means. It doesn't actually know what net profit means either. It's just summed actuals because that seemed like the most obvious numerical data point to aggregate. The query actually needs to bring in a chart of accounts as a table to join and filter on. So we need to join our actuals onto chart of accounts and filter where the header assignment is equal to revenue. And we want it broken down by organization. And again, it's not giving us exactly what we wanted here, but there's a few things we can do here to train this model. And that's the whole reason for having this custom model in the first place. As you can see here, there's the notes for model, which I've been copying some text into. And this is the system prompt. And it's here where we can tell it where to go to find particular things. So I've said in the system prompt, use the actuals column and join on the chart of accounts and use this for things like revenue and operating expenses. We tell it that when the user asks for profit margins, to calculate them, for example, as gross profit over revenue or net profit over revenue. So we're able to give it a bit of that context. And now when we're asking things like what is gross profit, we can see that it has actually worked that out. This one it hasn't worked out. It's worked out the chart of accounts, so it'll work out things like revenue. When we ask it for something like gross profit, because there's no lines in our chart of accounts called gross profit, it's a custom calculation. Now we did describe how to calculate that in our notes for the model, but it hasn't actually created that query properly. But it has picked up the chart of accounts sign, it's picked up whether it's revenue or expenses, which is also something that we described in the notes, but it's just giving us all the positives, less negatives. Another thing we can do is actually to help train the model is to give it an example query, SQL query for that prompt. So we could write the SQL queries ourselves and say, this is what you need to use as a SQL query for this example prompt. And it's an example prompt. So to write our SQL query, here we're opening up the lakehouse and using the SQL Analytics endpoint and drafting our own SQL query that answers a specific prompt. So here we have a common table expression, one for revenue, one for cost, and then return the gross profit for that month. Now, even though we've done the query for a specific month, when we put it into AI Skills, it's not going to take that literally. If you ask it for a different month, it will just take this as a general pattern for gross profit or gross margin when this is asked for in the prompt. In AI Skills, we give it the example prompt, gross profit for June 2022, and the corresponding SQL query that it should return. That will give us the right answer for that prompt. So now when we're asking for the gross profit for that month, you can see it's giving us a much more valid query. We can also ask for it broken down by organization, and it will be able to change that example query and adapt it as needed. So really quite powerful to be able to do that as well. Here we're asking for a breakdown for each month in the year, just like we asked for, and I think these numbers are correct. And once we're happy with this AI Skills model, and we're confident it can answer the scope of questions our users will ask, we can then publish it to be called via URL in a notebook, for example. So we say publish this AI skill, and now we can see the publishing details. We've got a URL here, which we can just copy to the clipboard. And clicking on learn more actually tells us how we can use it. It gives us the PySpark code to call it from a notebook. So we can pass in a question in a notebook and it will return the response. You can also use it in things like Copilot Studio. So you could build an agent in Copilot Studio and use this AI skill as a knowledge source. So then someone could go into Teams and ask a question And it will know that knowledge base and say, yes, I know where to get revenue and expense numbers from, and it will convert that prompt into a SQL query against the right tables and return the result. Lastly, we're going to look at building a custom RAG with Azure OpenAI, and we're going to use Python code in a Fabric notebook to do this. We'll start with calling our AI skill, then look at SemPy again, and then finish off by creating a vector search index out of a dataset generated from our semantic model. So firstly, to call the AI skill, we're just going to use that same code that it gave us in the Microsoft Learn article, passing in the URL and asking a question. What is the total revenue broken down by organization? And it's given us those answers there. As we run this here, we can see, and as I mentioned, one of the current limitations with our skills is that it's against lakehouse tables. So we can't use the outputs of all these measures that we calculated. So let's take a different approach by connecting the semantic model with SemPy, the semantic link library that allows us to connect to semantic models hosted in Fabric and query them using a DAX query. So we install the libraries, we list the semantic models in the workspace, and we can see all the ones there. We choose the one we want. We're actually choosing the input model here. It works with both import and direct lake models. It's now given us all the tables in there, and we say we want to view the relationships, and it's giving us all the relationships which we can call in a function to see in a nice visual diagram. There are standard functions to list out all the measures and even to run and evaluate DAX statement. So this is an example DAX query that I produced using the DAX query view as a starting point. So just using Performance Analyzer against the income statement matrix, copy that into DAX query view and just tweaking it a little bit to give us the income statement for every month. This is a really useful data set for us to use as a source for our model, perhaps more so than just the raw lakehouse tables without our measure evaluations. This has for each month the actual income statement values and ratios. I basically ran this and saved the output as a CSV file, which we can then load as a document into a vector search for us to be able to apply into an LLM and build our own custom RAG model. To do this, we start by importing the libraries. So we've got Llama Index, OpenAI, and this is just generic code that one of my ex-colleagues wrote to help me analyze something else. It's the same code, regardless of what is actually in those documents. So we load in the CSV file that we just had from the query in SemPy and pass in the OpenAI key. We load it into a vector search index. From documents, we've got the query engine and we can query the knowledge base. We provide some context as to what the data is here. We say these are income statements. Use this to provide a detailed overview of profitability, performance, explain the trends in revenue, gross profit, gross margin, and identify which items in the income statement are driving the variances. And it gives you a fairly detailed answer here. I've seen a bit better from ChatGPT, but as this is essentially a more raw version, I imagine I need to provide more context and detail. But it gives you some good trends and information there. And we've loaded it into Pandas data frame and asked it to give us a trends report. And now it's telling us their trends report and it's putting out those key metrics. And just like with ChatGPT, we can also be a bit creative with this. So we've said, produce a trend report in the style of a poem. And so you can see the poem there in July 2019. The company's revenue was this, which was lower. So this is the actual, this is the original one. And then here's the poem version in July 2019. Our revenue took a dive. But fear not, for our net sales kept our business alive. So a nice, fun thing to maybe stick up above your desk or something that makes for an interesting read at the front of your board pack, presenting the information in a way that makes it more memorable than just raw numbers and words. And so just to recap on what's been covered, we started looking at data exploration with Power BI Copilot as the first step. So loading our data pretty raw into Power BI and just asking it, what does this data tell us? What does it mean? What kind of analysis can we do with this data? We then looked at requirements and data model design. So here's about thinking about the specific audience that's going to consume our report and our AI skills and custom copilots, and what kind of questions they want, what kind of prompts will they be asking of the data, what kind of insights are they after, and what kind of measures and calculations, and what do we need to view and filter them by in order to be able to answer those questions or respond to those prompts. And then we have data shaping and transformation with Fabric. So once we've designed our data model, our facts and dimensions, essentially our numerical data points and with what we need to view and filter by, we then get from our raw data, so in this case, fairly raw general ledger data, into our analytical star schema data model using Microsoft Fabric, using data flows, with Copilot, using notebooks with Copilot, and really using those tools to help us shape our data. We then looked at building a semantic model from those lakehouse tables. So making sure we have the relationships, building the measures, the logic, and everything else that's going to help us, including descriptions. Again, using Copilot, that's going to help us really build that semantic knowledge, that context into our data. So it's more understandable both by humans and by Gen AI. We then looked at storytelling with Power BI visualization. So this was all about looking at the visualizations, the interactions that we could put onto a report in order to be able to produce the insights that we want. And this includes drilling down from the income statement into journal lines, for example, or hovering over a line and seeing the breakdown by month, as well as the interactions between the visuals, like the income statement and the waterfall chart. And here we also looked at the Power BI creation experiences with Copilot, so using things like the smart narratives visual and pointing out at different visuals and giving it detailed prompt, so it gives you a really rich narrative, and also the consumer examples, giving you an executive summary of what's on the page, and then asking data questions about your data from Power BI Copilot. We then looked at going from prompts to queries with AI skills and looking at how AI skills allows you to translate prompts into SQL queries that can then be answered by the engine, and you can publish that to a URL that could be called from a notebook, or can publish it to things like Copilot that can be consumed in Copilot Studio. And again, for custom agentic AI processes based on the data, this is the real engine behind it. And if we want to use documents, use files as our source as well, and we did an output of our income statement for every single month, exported that as a CSV, imported it into a vector search index, and then put Azure OpenAI on top of that to say, query this and tell me what's the trends in my financial data. Write me a financial summary that I can do in an investor relations meeting, for example, and actually do that in the fun style of a poem just to finish off. So I hope you found this useful, and if there's any questions, please let me know.